Wi-Fi antenna connector placement. Think of the Wi-Fi antenna as the vocal cords and ears of a laptop. While the wireless card itself generates the signal, the card is usually buried deep inside the metal and plastic chassis of the base, surrounded by electrical interference from the motherboard. If the antennas were located down there, your laptop would struggle to get a signal from a router in the next room. For the CompTIA A+ exam, you must understand the engineering behind antenna placement and the delicate nature of the connectors. As a technician, repairing or replacing a wireless card requires mastering the microscopic physical connections that make wireless networking possible. Part 1, Strategic Placement, the display bezel. To get the best possible radio frequency, RF, reception, an antenna needs to be as high up and as unobstructed as possible. In a laptop, the highest point is the top of the screen lid. 1. The routing path. The actual antennas are flat, foil-like transceivers stuck to the inside of the laptop's plastic display bezel. From these foil pads, two incredibly thin coaxial cables run all the way down the sides of the screen, pass through the mechanical hinges of the laptop, and plug into the wireless card on the motherboard. 2. The material challenge. Antenna placement dictates laptop design. Radio waves cannot easily pass through solid metal. If a laptop has a solid aluminum lid, like a MacBook, the manufacturer must either place a plastic window at the top of the lid for the signal to escape or route the antennas into a plastic hinge cover at the base of the screen. Part 2, the coaxial cables, main and aux. When you look at a wireless card, you will almost always see two distinct wires connected to it, usually one black and one white, or sometimes one black and one gray. Main and auxiliary. These cables correspond to the main and aux terminals on the Wi-Fi card. Modern Wi-Fi standards, like 802, 11AC and 802.11ax, use a technology called MIMO, multiple input, multiple output. This means the laptop is using multiple antennas to send and receive separate data streams simultaneously, bouncing signals off walls to increase speed and reliability. Shielding, these are not just simple copper wires. They are microscopic coaxial cables. They have a center conductor surrounded by a layer of insulation and a braided metal shield. This shielding is critical because the wires have to run right past the LCD screen's electrical components. Without the shielding, the electromagnetic interference, EMI, from the screen would drown out the Wi-Fi signal. Part 3, the microscopic connectors, UFL and MHF4. This is where technicians must exercise the most caution. The antenna wires do not solder onto the Wi-Fi card. They use tiny, snap-on connectors. The UFL connector. Found on older mini-PCIe cards, this is a small, circular gold connector. The MHF4 connector. Found on modern M2 wireless cards, this is an even smaller, flatter version of the UFL. It is barely larger than the head of a pin. The golden rule of connectors. You must handle these with extreme care. They operate like microscopic snap buttons on a jacket. To disconnect, never pull the wire itself. If you pull the wire, you will rip it cleanly out of the metal connector head, requiring you to replace the entire antenna assembly, which means dismantling the whole screen. You must use a plastic spudger or specialized tweezers to pop the metal head straight up and off the terminal. To connect, you must perfectly align the circular head of the antenna wire over the terminal on the Wi-Fi card and press straight down. If it is misaligned and you push too hard, you will crush the gold ring, permanently destroying the connector. Part 4, troubleshooting antenna failures. When a user complains about a weak Wi-Fi signal or frequent drops, the antenna is often the culprit, not the Wi-Fi card itself. Here is your professional diagnostic path. 1. The hinge test, physical fatigue. Because the antenna cables pass through the laptop hinges, they are bent and twisted every single time the user opens or closes the lid. Over the years, this constant friction can pinch or sever the delicate coaxial wire inside the casing. Diagnosis. Ask the user to connect to Wi-Fi and slowly move the laptop screen back and forth. If the Wi-Fi drops out at a specific angle but reconnects when the screen is pushed back, the antenna wire is severed inside the hinge. The entire antenna assembly must be replaced. 2. The pop-off, mechanical shock. If a laptop is dropped, the physical shock can sometimes cause the microscopic UFL or MHF4 connectors to simply pop off the Wi-Fi card. Diagnosis. The laptop will report that the Wi-Fi adapter is working perfectly, but it won't be able to see any networks, or it will only see the router if the laptop is sitting directly next to it. The fix is simply opening the bottom case and snapping the cables back into place. 3. Incorrect reassembly. If a fellow technician recently replaced the Wi-Fi card or the motherboard, they may have accidentally swapped the main and aux wires or failed to seat one of the connectors fully. Always double-check their work. Summary for the professional technician. To lock this in for your exam preparations. Placement. Antennas are placed inside the top of the display bezel to maximize signal strength and avoid interference from the metal chassis. MIMO technology. Multiple cables, main and aux, are required to support modern, high-speed Wi-Fi standards. Connectors. They use incredibly fragile UFL or MHF for snap-on connectors. Never pull them by the wire. Vulnerability. The cables route through the mechanical hinges, making them highly susceptible to wear, pinching, and severing over time.